This is a revision on matrices work from the AS Further Maths content in preparation for looking at matrices in A2 Further Maths. So I just want to cover some basics, the essential things that we need to know about matrices in preparation for learning a bit more. So I want to have a look in this really at the crucial elements of multiplication. We'll cover a few basics before this, but really the essentials here are on multiplying matrices together. And then we'll also look, possibly in different videos, depending on how long we take. We'll also look at determinants of a matrix, or the determinant of a matrix, finding an inverse where we can, and we might have a look at some solving equations as well. So just a few basics with an eye on multiplying them. The first thing we need to know is just to be able to refer to the size of a matrix, or more commonly referred to as the dimensions. So we talk about the dimensions of a matrix in terms of its the number of rows and columns that it has, and we do it in that order as well. So if I talk about an m by n matrix, what I mean is that the matrix has m rows and n columns, and it's always that way around. The first of the two numbers is always going to be the number of rows, and the second of the two numbers is going to be the number of columns, and that's a convention that everybody follows. So, for example, if I have something like that, where the dots are would be numbers, or if it's an algebraic one, there might be algebraic expressions in each of those positions. This would be a 2 by 3 matrix. And one important subset of matrices, of all possible types of matrices, is square matrices. Obviously, same number of rows and columns, and much of the work that we'll be doing is based around square matrices, but they don't have to be square, and we certainly will be using matrices that aren't square. Thinking about multiplying two matrices together, the dimensions of the matrices that we're multiplying is important. You'll remember that if I multiply an m by n matrix, by I don't know, J by K matrix. It's if these are the dimensions that we're talking about here, this is only possible if n and j are the same. So we have to have the same numbers. We have to have the same number of columns in the first matrix as the number of rows in the second matrix. And if that is the case, and we perform the multiplication of these two matrices, then the other two dimensions that we haven't used, so the first number in the first matrix and the last number in the second matrix, those two tell us the result. So as long as n and j are the same, so actually I would be doing an m by n matrix, multiplying an n by k, because those two have got to be the same. So as long as those two are the same, this is going to produce a matrix of size m by k. So a 2 by 3 matrix multiplying a 3 by 1 matrix will produce a 2 by 1 matrix, or something like that. The next thing to recognize is that the order of multiplication is crucial. In general, if I have two matrices A and B, and if it's possible to multiply them together, if I do multiply them together, then if I multiply them together in that order, A, B, that's not necessarily, sometimes it will be, but generally speaking, it's not going to be the same as multiplying them, if I can again, in the other order. So AB is not equal to BA generally. Occasionally it will be, as I say, but in most cases these two things are not the same, and that's fairly relatively obvious just by thinking about the dimensions. If I multiply 2 by 3 by 3 by 1, then I get a 2 by 1, but if I multiply them the other way around, so 3 by 1 times 2 by 3, then the numbers in the middle there are not the same, and so the multiplication is not possible. So those are the general principles to remember about thinking about the size and the order of the matrices and the order of multiplication, the size of the matrices and the order of the multiplications. Next thing to think about is just, well, how do we actually do the multiplication? So just as an example, so if I take a 2 by 3 matrix like this one, 5 minus 1, 2, 8, 3, 4. So remember dimensions there, 2 by 3, 2 rows, 3 columns. And if I multiply that by this matrix, 2, 2, 9 minus 3, 7, 4, which is a 3 by 2 matrix. So I've got the same numbers in the middle here. So this multiplication is possible, and those two numbers there tell me that the resulting matrix should be a 2 by 2 matrix. And I'm not going to go through all of that there. I'll tell you what it is. So you can check that on your calculator. It is important to be able to do these multiplications on a calculator because of accuracy and speed. But it's also very important to be able to do these without a calculator as well, because you may well have to do this algebraically, where you don't know the values of everything in the matrix. And so yes, important to be able to do it by hand as well. So just thinking about how do I get those numbers 15, 21 and 15 and minus 9, let's just focus on one of them. Let's take, say, that 15 down in the bottom left-hand corner. So I can find the result of any particular element in the answer matrix by thinking about its position. So this is in the second row and first column. So it must have come from the second row of the first matrix there, and it must have come from the first column of the second matrix here. So 2 from here, 1 from there, producing the 2 and 1 position, the position, second row, first column, 2 and 1. And I get that 15 there by doing 8 times 2 plus 3 times 9 plus 4 times 7. Sorry, something must be wrong there. That should have been a minus, shouldn't it? That's why. So plus negative 4 times 7. 8 times 2, 16. 3 times 9, 27. And then take away 28. So that's where I get my 15 from. So we're going horizontally through the first of the two matrices and vertically down the second of the two matrices each time. which is why the number of columns in the first matrix has to equal the number of rows in the second matrix, because 3 entries in the first row of the first one need to match up with 3 entries in the first column of the second one. So the number of columns in the first matrix has to equal the number of rows in the second matrix. So that's how we go about multiplying them together. Clearly, this actually is a pair of matrices which I could multiply together in the opposite order, because the 2's on the outside would then switch around and become the 2's on the inside, and that so multiplying them in the opposite order would give me a 3 by 3 resulting matrix. So that's how we multiply matrices together.